set, if we didn't read by S, then it must be a collection of finite or infinite numbers uh, which we use in our daily life. So collection of alphabets like E, B, C, D, dot dot up to infinity I am taking. A finite set can be done this way by taking natural numbers like 1, 4, 7, 8, 12, this way. This is infinite set, this is finite set. So number of elements in the set, in this set S1 is just 5. So in this way the definition, the set can be defined. Now if we take I'm now going to some operations in on set like addition, subtraction, how we can do this on set. First, here addition is called union and subtraction is called intersection. So I am going now about to discuss union of two sets. So I am taking two sets like A. I am taking some elements. A consists of A, B, C, D, E. 5 elements I have taken in the set A. In the set B, I am taking sets C, E, F, G. 4 elements I have taken in the set B. And now I am taking another set just to define more briefly and in good way. I am taking another set C also like A, and in this set I am taking 3 elements A, E and H. So how we can add this 3 set or so I am taking union of these 3 sets. First I am taking union of 2 sets. So how we can add up 2 sets? So here there are 5 elements in the set A and 4 elements in the set B. So we have to take all these elements, but common elements like C, like E cannot be written twice. We will take all elements, but we cannot take common elements twice. So in this set A union B, we have A, B, C, D, E, F, G. So all the elements belongs to A and B in this set. B set can be found out also here. B set is C, D, E, C, E, F, G, 4 elements. The A set also we can be found out in this union A, B, C, D, E. So this is the union where A and B both the set can be found out in the union. And if we depict a diagram here, Venn diagram this is called, then we have to take a set which is called universal set. Universal set means a set in which overall we can generate all those sets from our daily life. So all the sets we can formulate comes under this universal set. So this is the set which consists of all the sets we can generate. So we are taking a set here in this way. This is a set A, and another set we are taking set B. Since two elements are common, C and E, so we can write down in this way. This is the set B. So here A, B and D elements are not in the set B, but C and D are common elements. These come in this set, in both the sets. In C and D comes in A set, also in B set, and some elements do not belong to set A, which are F and G. So we write down in the set separately in set B. So all these elements comes under now A union B. A, B, C, D, E, F, G up to. So in this way, by marking the whole area, we can say that this area under universal set comes under A union B, or or under universal set. Now, what is intersection set or subtraction of two sets? So subtraction of two sets or union, intersection can be written down in this way. This is lower cap, this is upper cap. So through lower cap the intersection is symbolized. So here we will just take the common elements like C and D. These two elements belongs to all both the two sets. So yes, is this area, dense area, which belongs to both the set A and B, can be symbolized A intersection B. This is A intersection B, and the whole area here A set and B sets and A intersection B also comes under A union B. So we can very easily write down that number of elements in A union B is equal to number of elements in set A plus number of elements in set B. But here problem is that the intersection elements which we have to take once, but here if we take a number of elements in A and number of elements in B, here the intersection elements are taken twice. So we subtract this number of elements A intersection B cannot be taken twice, so we subtract one times, so that a number of elements in A union B can be generated. So this is also a formula we have to remember to solve many problems. Now if we go in complement, what is A minus B will be? A minus B means that elements keep in A keeps in A, but if those elements found both in A and B cannot be carried out in A minus B, means that here A and B, here two elements C and E are common, so we cannot write down C and E into A, and the B elements cannot be carried out in A union B, means we have just three elements A, B and D, so should be in A minus B. And we also subtract B minus A complement, B minus A. This is also written in this way, A complement and B, this is called B complement. So here also all the elements of A cannot be find out in B. So we will get just F and G, these two elements which can be in B minus A. So this is called B complement. So if we now add up A complement and B complement union, then what it will be? It will be just A complement elements are A, B, D, F, G, and its intersection must be null set. Null set means, what is null set? Null set means there will be no element in this set, just one element, null element can be in the set and other no element can be in this set. So in the intersection there we will not get any element which is which belong to both the set A complement or B complement. So in this way we can add up two complement set, or we can find out intersection of two complement of sets. So we have to know what is universal set or what is null set. Now I am going to discuss some mappings. What is mapping? Mapping or a relation between two sets, how you can map a set to another set. Like we are taking a set A in this way, and there are, I am taking four elements A, B, C, D, and another set B. This is set A, another set B. Here I am taking five elements B, C, D, E, F. So a mapping or a relation denoted by F from A to B can be defined in this way, that A means elements are common or similar. This mapping is that a mapping is defined in that two elements are common in both the set. This way this relation mapping defined. Two elements are common on both sets. So here this type of mapping can be variable types, like one is on-to or injective, and one kind of into. This means so and onto, and one can be into, and another is one to one, so subjective also. And four number onto I have already said. The fourth number is many to one. So onto means like if we take a mapping from B to A, here there are 5 elements and there are 2 elements, and for all the elements there must be a element here. So here we are finding, first time I am going into onto. Here onto means that there are if from A to B we consider, for all elements A, I am taking an element here from for if we not consider these elements, we consider that for every element A there is an element in set B. For B set there is an element D. For C set there is an element C, and for D set there is an element F. Then one element E keeps in the set B. So it does not have any pre-image in the set A. So this is called into mapping, because there we can find out an element which does not have any pre-image in the set A, which can map in the set B. So this is called into mapping. And if we take in this way a set B dash, which is a set B dash in this way, that it is formed by B complement of 2 elements I am now not considering. This is D and F. This is E. Then we can find out that in this set B dash, A to B dash, now B dash now have all the elements which have a pre-image in the set A. So this is now is onto mapping. This is called onto mapping, and the previous one was into mapping, because there was extra one element we can find out which does not have any pre-image in the set A. And here now the B set which does not have any extra element which does not have any pre-image in the set A. This is called onto mapping. And sometimes this can happen that from one set A and from another set B or C, we are taking in this way A, B, C. Here we are taking two elements 1, 2. So A and B maps same element 1, and C maps any element 2. So here I have taken one element to one element. This is called 1 to 1 or surjective mapping. But here two elements maps just only one, two elements or more than two elements maps one element in the another set. So it is called many to one mapping. And sometimes we can get many mapping. that is 1 to also and 1 to 1. These are called bijective mapping. So bijective mapping needs it should be subjective plus injective mapping plus injective mapping. Then the mapping is called bijective and injective.